Hello guys, today I'll be talking a circuit analysis technique, which is a mesh current analysis. So this is another way of doing circuit analysis in addition to nodal analysis technique. So similarly, for example, if we have a large network, we must be able to do or to analyze using a mesh analysis technique. Okay, so to do that one, well, we have to define what is mesh current and how we should be able to define the Kirchhoff's, the equation using Kirchhoff's voltage law. Okay, using the mesh currents, and then of course, a mesh current or a mesh is a loop that does not enclose any other loops. Okay, so for example, if we consider this circuit, we have R1, R2, R3. Okay, as you can see. If we look on here, R1, R2, R3, and then we have three voltage supply, V1 and V2. So the mesh is we can just apply this mesh, in a network. So IA and the IB are mesh currents. So the current flowing in R3 is IA minus IB. The reason for that one is because IA is going down across here, but IB is coming this way and then it's going up the other way. Okay, so this is going down, up, sorry. So the difference IA minus IB is difference in current is the current that flows to the R3. Okay. So mesh current analysis technique is very simple and easy. Okay, so we must be able to understand first of all. So in using nodal in here, I1 is technically I2 plus I3. So we can re-equate I3 is plus I1 minus I2. Okay, and then V1, which is this one, is I1 times R1. So I1 times R1, which is the voltage across here, plus the voltage across this one. So that means I3 times R3. Okay. And then the voltage across here, V2 or minus V2, because we're doing this way, the opposite way, is equals to I2 times R2, which is the voltage across here, plus the voltage across R3. That is minus R3, sorry, minus because we're going the other way, minus I3 times R3. This times this. From that, we can re-equate this one, this two, and then we can have this equation. So if we apply the mesh current technique, well, what we can do is then IA times R1, we just look in the simplest way like this, plus their difference, because we're going IA down and then IB is going that way. Okay, so that IA minus IB times R3. So this is one equation for in the loop or in the mesh current IA. The other one is on here. On that one is minus V2 equals to IB, because we're going this way, IB minus IA, which is the one current going down, times R3. In here, plus, because this is going this way, then because of the IV is going that way, so IB times R2. So now this is using mesh current method. Okay. So from that we can just do the simultaneous equation and we can just recalculate everything. Okay. Well, let's have a look at the example in here. If we want to find if we are asked to find a voltage across this one, across 8 ohm resistor, well, how do we do? So we must be able to define, the mesh current method. So we have to able to, find what are the essential nodes, and then essential branch. For example, we have essential branch 3. And then we have to apply n minus 3, n minus 1, sorry, branch minus essential node minus 1. Okay, that means, for example, we have at least in here, just get a pen, and then we have essential node in here, and then essential node in here as well. Okay, but we can apply mesh 1, mesh 2, and mesh 3. So that means that at least we have 3 meshes. Okay. Okay, so as I said, IA, IB, IC, we can apply 3 meshes, and then we have to write the equations, Kirchhoff's voltage law, around each mesh. Well, it's very easy. So for example, like we can write in here, minus 40 volt plus 2 times IA plus 8 times IA minus IB equal to 0. So that we make this one into as the Kirchhoff's voltage law. And the other one is in here, IB. So in here, we can start with this one, so that IB minus IA times 8. We start this way. And then IB times 6, which is this one. And then we go this way, because we're going down, then IB minus IC times 6. IB minus IC times 6, yeah, equal to 0. Okay, that's the other one. And then from that, the rest of the last one is then IC minus IB times 6, and then IC times 4, which is this one, and then plus 20 equal to 0. Okay, so this is the equations. From that, we can re-equate them, and then we can find IA is equals 5.6, IB to IC is equals to minus 0.8 amp. So in here, we can just put this IA is 5.6, and then on here IC, in here it is minus 0.8 amp, and then IB obviously in here is 2 amp. Okay, well, then we can calculate again the power across each. Okay, so I've also measured that, the current across each branch. As you can see, 5.6 in here is this, 2 amp is this one, and then IC is this one, 800 milliamp, or minus 0.8 amps. Okay, and then of course the power for each is here. As you can see, the power across here is minus 224. Okay, this is because it is the negative means it is delivering or providing power. Okay, and then the voltage across 8 ohm resistor is how much? 28.8, which is this one. Okay, so if you look on here, this is what it means. I'll run this one. So the voltage across here is 28.8. Okay, well, we can always measure voltage at any place. At any place, you just use the voltage in here and in here, as long as we must not forget how to the ground. Okay, and then I can just plug it in here and run. So the voltage is now reduced in here, 60.8 volt, because of this resistor. Okay, if this resistor is null or 0, then the voltage must be equal to this one, isn't it? Because they are in parallel. Okay, Yeah, so yeah, that is the mesh analysis now. If we know the equation, how to create the equation for each, then we can be able to find the current across it, and from that we can calculate the power. Okay, so in nutshell, we must in mesh current, we must identify the branch or essential branch, and then we can apply this equation to find how many meshes do we need, and then from that we can calculate the Kirchhoff's voltage law and solve the equation. Okay, thank you for listening. Thank you.